Okay, in this video homework, first of all, I have the given condition that the density function of fxy equals a minus a multiple square of y, and the given area of the thing. In the first question that I need to make sure the value of a. From the area, I can join it in the picture. It's this one. So from the property of distribution function, I can use integral to integrate the whole area of the joint density function of fxy. So the output should be equals to 1. So the value of a equals 6. The second question that I need to calculate the marginal function of fx. The marginal function of fx equals to the integral that integrates the y. From the y, I can say the vertical line that is y, which going through the 2 points on this area. The lower point is y equals to 0, and the second point, that is upper point, is on this line. If x, the area of x equals to minus 1 to 0, this point should be minus x. If the area of x equals to 0 to 1, so the upper point should be y equals to x. So there are 2 areas. So from this part, I use 2 integral respectively. So I drawing the conclusion that if x equals to minus 1 to 0, the density function of x equals to minus 2 multiple the third times and x. And in second situation, when x equals to 0 to 1, and I get this value of output. So using the similar idea that I can calculate the marginal function of y, and drawing the 2 pictures of x and y. X is like this and y like this. The first question is to calculate the conditional density function of at y when x is given. So from the equation, I can get this equation and introduce the previous outputs to this one, so I can get this conditional density function. And using the similar way, and I can get the second conditional density function when y is given. So using the equation, I can get this output. In the sixth question which led me to calculate the average value of x, y, and conditional when x is given, the average of y, and y is given, the conditional average of x. So the first is to calculate the mean of x. So using the equation and the formula, I can get this integral that using the Magrino function of x and x. So because of the different parts in the area, that I should separate this integral into two parts. The first part is when in this line, when going through these parts, that is the first part. I mean, the right points of x is -1. The left points of x is -1, and the right points of x in this area it's y. Yes, it's -y. And in the second area, in this area, that the left point is x, the right point is 1. So I'm able to calculate the whole integral by using two separate integrals. So using the similar idea and way, I can calculate the mean of y. In the third part, that I should calculate the conditional mean, that when x is given, to calculate the mean of y. So using the formula and separate the thing into two parts, like previous one. So I can get this output and this output. In the last question, that when y is given, so using the similar idea, but in this way, I can say that when integral x, the x is a odd function, and the area is even. So using the property of the function, I can get the output equals to 0.